In the last class, we have discussed about one solution, and we have trying to understand that whether it is satisfying all the condition of mutual exclusion or not. Oh, sorry, all the condition of critical section or not, right? So in this particular solution, what we have found that that this particular solution is only able to preserve mutual exclusion, and it cannot preserve the progress, as well as it cannot preserve the bounded weight. So these two are the criteria that also need to be satisfied, which is not satisfied here. Now, what we are going to see today in today's lecture is we'll see some more solution and try to understand which solution will be appropriate for the critical section. So in this solution, if you see, we have a while loop. In that we have only 3-4 instruction. The first instruction is a while loop, in which we have seen the turn value. Turn value is if it is not equal to 0. If it is not equal to 0, then will not allow this P0 to go to the critical section. If it is equal to 0, then we'll allow it to go to the critical section, and then after that the exit condition is to make turn value as 0. In the same way, for P1, we have a condition like the precondition is turn does not equal to 1. If it is 0, we are not allowing to be in the critical section. If it is 1, then we'll allow this particular process to go into the critical section, and the exit condition is to make turn as 0, and then the remainder section is going to be executed. So in this particular solution, we have found that this is preserving the mutual exclusion. Mutual exclusion means if one process is in the critical section, so in the same critical section will not be allowed to other process to go into their critical section. So it means that if one is processing the shared or updating the shared resource, so other process is not at all allowed in that particular resource to be updated. Now, what the progress? The progress says that if the critical section is free, so no other process will oppose the other process who are interested to go into the critical section. So as well as if one process is not interested, you cannot make it forcefully to go into the critical section. So these two conditions, if it is there, then the progress will be preserved. So here we have seen that this in this particular algorithm, or in this particular solution, we found that it is showing the strict alternation. Means if P0 has executed its critical section, so this algorithm allow P1 to execute to its critical section. It is a strict alternation, and if P0 again want to go to the critical section, cannot go. As well as if P1 is not interested, then forcefully we are saying that that particular process to go to the critical section. So that is not progress, and that progress is not at all satisfied in this particular solution. The third condition is the bounded weight. Bounded weight means if somebody is interested, then we'll allow it to go to the critical section after a bounded period of time. But here we are not taking any type of that agreement type of thing, that somebody is agreed to go or somebody doesn't want to agree to go. So that agreement we are not taking here, or we doesn't have any provision to take the agreement here. क्या था?
तो हमारे आईएससी प्रोजेक्ट का 1 लाख का फॉर्म है ना,
The security is a related book. ठीक है, मैं भिजवा दूंगा लिस्ट,
फ्राइडे तक
आज ही भिजवा देते। कितना कितना चाहिए, कितना लिस्ट चाहिए? ठीक है, आज भिजवा देते। Okay, so here in this particular solution, bounded weight is also not preserved. Bounded weight says that according to the interest of the process, you have to allow that process to go into the critical section, and another process will not going to restrict that particular, or will not going to make any obstacle if any interested process want to go to the critical section, and if the critical section is free. If the critical section is not free, then also we'll take the interest of the process and we'll put it somewhere, so that other time if critical section is free, so we'll allow that particular process who are showing the interest to go into the critical section. That is called bounded weight, and bounded weight is also not preserved here. Now, let's go to the other solution of mutual exclusion and try to understand that how it is happening. So right now we are in the two process solution. Okay, so two process solution means we try to understand that do we have any algorithm or any solution which will work for two processes. So once we'll get it, then we'll go to the n number of processes. So let's go to the other one and try to understand that how other solution and try to understand how it works. So we know that if some process is there, we know that if any process is there, so that particular process need to go to the entry section and then if it will satisfy the entry section, then only we'll allow it to go to the critical section. And once the critical section will be executed, that particular part of the code will be executed, it will execute the exit section part or the exit condition part, and then the reminder section is there, in which is a reminder section of the process. So you see this particular part from here to here is the part of any process that will be required when it want to execute its critical section. So there is an entry section, there is a exit section, and in between we have a critical section. Now let's try to understand the solution that we are proposing. So we are proposing a solution again for the two process. So we have process P0, and this process P0 will be having a while loop, in which this while loop is going to be executing all the time because it is always true. And inside that we have entry section code which says that while turn, sorry, we have taken another variable called flag, and we'll see flag of 0 will be true. We are making flag of 0 will be true, and then we have a entry section code in which we are looking for the flag value of 1. If it is true, then it will go into the loop. Otherwise, it will come out from the loop and execute its critical section. And then there is a exit section where it will make it flag of 0 equal to false, and then it will execute the reminder section of it. So if you want, you can write it here. Reminder section. Okay. Now this is about P0. Let's go to and write the code for P1. Here also we have a while. Inside that, flag of 1 we are looking for, and we are making to true. And then we have a loop. This is an entry section in which it will see the flag of 0, and if it is not satisfied, it will go to the critical section. And then the exit section, it says that flag of 1 will be equal to false, and then it will execute the remainder of the section or the remainder of the codes which are there in the process. That's all. So this is another solution. So if you can understand, we have this particular part is nothing but the entry section that we'll use, and this particular part is nothing but the exit section that we'll use, and this is your critical section, right? This is your critical section. Here also we have this critical section and this particular part, and this particular part is your entry and exit section respectively. Let's try to understand the solutions for that. Now, if we'll come to this particular code, so we'll start with flag value. And we have this flag. Flag is nothing but an array of two values, 0 and 2. So this is the 0th position and this is 1 position, right? So in the 0th position, let's at the very beginning, the 0th position, and this is the position of 1. At the very beginning, let's assume that both are false. Let's assume that both are false. Okay. Let's see, initially both are false, and we'll try to execute P0. So let's see, it will go to the first one. It will make it flag 0 to true. So what we do is this particular flag 0 value is going to become true because it is making to true. And then is a while loop. It says that flag of 1, and it will look for flag of 1. So what is flag of 1? Flag of 1 is false. So this while loop is exiting, means it is not going to satisfy. So it will exit and will go to the critical section. And P0 will execute its critical section. And once it executes its critical section, it will go out from it. And it will make flag 0 as false. So right now, what is flag 0 value, which we made it true, it will become false. Got it? Now, what about now? Now, can again P0 can go to the critical section? Yes, P0 again can go to the critical section because we are in the initial state, right? So false and false. Can P1 go to the critical section? Yes, P1 also can go to the critical section. How? So with this particular condition, let's go here. Flag 1 is equal to true. So we are making flag 1 as true for the process 1. While flag 0, so what is the value of flag 0? Flag 0 is false, so it is false. Then we are going out from the critical section. Going into the critical section, and critical section will be executed. And after that, we have this flag 1 is equal to false that we have to do. So what we have done is true, we'll make it false. Right? Now what happened here is, in this particular code, we can say that it is satisfying the mutual exclusion. It means that if one process are in the critical section, another process cannot go to the critical section. Let's see this, whether it is satisfying mutual exclusion. The first condition, mutual exclusion. The second is progress. And the third one is bounded weight. So let's go for the mutual exclusion first. So if let's say P0 is in the critical section, so what will be the condition? If P0 is in the critical section, so flag of 0 will be true, right? So we have to make flag of 0 will be true. So we'll make it false to true. And then the condition is there, flag of 1. Flag of 1 is false, so definitely this while loop is not going to execute. We are coming out of the loop and going to the critical section. Now P0 is in the critical section. Now what happened is P0 has preempted, and now P1 want to execute into the CPU. Now this is the value of the flag right now. Now what happen if P1 will come? So if P1 will come, so it will make it P of 1 as true. So P of 1, it is false right now, so we'll make it to true. And it will look for the condition flag while flag of 0. What is flag of 0? Flag of 0 is true. So while condition is true, so it will be in a loop. It means that because P0 is in the critical section and we have preempted it from the critical section, it means P0 is already there in the critical section. In this particular critical section, P0 is already there. So P1 is not going to allow. It will be in a loop all the time. So this particular loop, it is going to execute the loop all the time. This particular while loop, it is going to execute all the time. Why? Because it is finding that flag of 0 is always true. Once that P0 is out from that particular critical section, then what will happen? It will make it flag of 0 as false. This will become false. Then only P1 will come. Why P1 will come? At that particular time, flag 0 is false. So we are out from the loop and then critical section, and then P1 will come here. So in that particular thing, we can say that if one process is executing the critical section, then other process will not be allowed to go to the critical section. The same thing we are doing in the last solution also, means mutual exclusion is preserved here, means it is satisfying the mutual exclusion criteria. Now let's go to another criteria which is called progress. This is the initial thing, right? Now what is the meaning of progress? The progress is that if one process is interested, then other process is not going to stop it. Or if one process is interested, then we have to give the critical section to execute to that particular process. So let's see whether the progress is preserved here or not. Let's say in the initial condition both are false, and P0 is coming into this critical section, want to come into the critical section. So it can come, yes, it can come. It will make this particular false to true, and it will see that flag of 1, it says that process 1 is interested or not. So here process 1 is interested. No, it is false. Means process 1 is not interested. It will go to the critical section. And at that particular time, we have seen that nobody is allowed. Let's say it is out from that particular critical section, and then it will make it flag as false. It will make it flag as false. It will make it flag as false. Now at that particular time, can P1 will be getting into the critical section? Yes. So it will make it flag as true. It will make it flag as true. It will make its flag as true, means P0 is interested to go into the critical section. Then it will see whether P0 is interested to go into the critical section or not. No, it is false, because P0 is not want to go to the critical section, and then P1 is going to be executed here in the critical section. So you can see that if somebody is interested, it will allow into the critical section. If somebody is not interested, it will not allow. Second thing, if other process is interested, then what will happen? Let's see another scenario. We'll again start from the beginning. Let's assume that P0 is going into the it want to execute the critical section. So it is executing this particular code. It says that P flag of 0 will be true. So we'll make it flag of 0 will be true. It means that P0 is interested to go into the CPU, into the critical section. Now it will look for the while loop. Before that, before going to the while loop, here at that particular time, that P0 is preempted. We know what is the meaning of preemption. Means forcefully will deallocate the CPU from P0. Now P1 want to execute from here. Now if P1 want to execute from here, it will, what it will do is it will go to the loop and it will make it flag of 1 as true. So it will also make it flag of 1 as, it means that P1 is also interested. So it will make this particular flag as true. And then it will go to that particular loop. It says that flag of 0. What is flag of 0? Flag of 0 is true already. So it will be in a loop. Means it will not allow to go to the critical section. Why? Because P0 is already interested. Now can P0 can go to the critical section. So let's say after that it will be preempted. And P0 will get the chance, because P0 has already done this particular code. It will go to this particular code. It says that while flag of 1. So what is flag of 1? Flag of 1 is true. It is also true. So P0 is also going to wait. P0 is also going to wait. And P1 is also going to wait. Whom they are waiting? They are waiting to each other to release that particular flag value as false. But both can be stuck. That is called deadlock situation. In this particular scenario, P0 has shown its interest. So P1 cannot allow into the critical section, because P0 has already shown the interest as true. And by doing this particular, by executing this particular code, P1 has also shown its interest that it want to go. So P0 cannot go to the critical section, right? So if both we are doing, then it says that in this particular scenario, we can say that P0 is waiting for P1 to release, and P1 is waiting to P0 to release. Both are waiting for each other and going to the deadlock. In this particular situation, we can say that progress do not preserve here, because progress says that if one is interested, it can go, as well as if one is waiting, it has to wait for a bounded wait, mean for a certain period of time, not for the infinite, because here it will go into the loop. Both P0 and P1 is going to the loop all the time, so definitely it will go into a infinite loop and nobody can go out from the loop, and the progress is not going to satisfy if this particular situation occurs. Now, what is the meaning of bounded wait? Bounded wait is again the same thing is there. If one is interested, then it has to wait for a bounded period of time. But here it is waiting for the infinite period of time, because here also is in the loop, here also is in the loop. So bounded wait is also not preserved here. It is here is an infinite loop or infinite wait. So both these progress and bounded wait is not satisfied here. The same thing is happened in the previous code also. Progress and bounded wait was not satisfied. Only mutual exclusion was satisfied in the previous solution also. Now let's go to another solution. The enhancement of this particular solution. Now, what is the enhancement? The enhancement is we'll add one more variable called turn. Okay, so instead of flag is there, but we'll just add another variable called turn. So let's see the solution for that. Now here you see we have process P0. We have a loop. Here we have a flag, the same thing what we have seen in the last solution. Flag of 0 equal to true will make it. It means that P0 is interested to go into the critical section. We'll make it turn. We'll make it turn equal to 1. So this is another variable that we'll have to update. And then we'll look for the entry section. So what is the entry section? Entry section is the while loop, and it will look for the turn if turn is 1 and flag of 1. Flag of 1 is equal to true. If both the condition is satisfied, it will be in the loop. If any of the condition is dissatisfied, it will come out and execute its critical section. And in the exit section, we'll make it the interest. It means the flag as false. Because we are out from the loop, so we'll make it flag as false. Now let's go for the solution to P1. Here also we have while loop, and the code is going to execute is it will look for flag of 1. It will make it true. It means that P1 is interested in the critical section, and it will make turn as 0. And then there is an entry section. In this we have a while loop. It will see this turn is equal to 0 or not. If it is 0, it will look for another condition, say flag of 0 is equal to true or not, means other process, means the process 0 is interested to go into the loop, into the critical section or not. If P0 is interested, then this particular is true, and turn of 0, turn is 0, then also this will be true. Both are true, then will not allow the process to go to the critical section. If any of these will be false, then will allow to process to go to the critical section. And then the exit condition is about the flag. It will make it flag equal to false. And then the remainder of the section is going to execute, and this is how it happens. So I think you understood this code, right? So this code says that we have two variables. One is the turn, and another is a flag. About the flag we already know. So this is the 0th position, this is 1 position, and initially we'll see this is false. Turn, we can take it initially as anything. We can make it 0 or 1, whatever you want to make it, you can have it. Let's see and try to understand that how this solution is going to work, and whether our mutual exclusion is satisfied. So the first that we'll look for is mutual exclusion. Second, we'll see the progress. Third, we'll see bounded weight. Okay, let's go to and try to understand that how the execution take place. So let's take flag 0 as false and 1 as false. And the first one that we'll look for is okay. So the first one that we'll look for is the P0. If P0 want to execute, then what will happen? So if P0 want to execute, then flag 0 will be true. So we'll make this particular flag 0 will be true, and turn will be 1. So we'll make turn value will be 1, and then we'll see the while loop. While loop says that turn equal to 1. Yes, it is equal to 1. So this is true. And flag of 1 is equal to true. Flag of 1 equal to true. No, flag of 1 is not true. It is actually false. So because it is true and false. So because it is AND operation, so true and false will be false. So if it is false, so it is not going to execute into the, or it is not satisfied, so it will not be in the loop, and it will get out from the loop and execute its critical section. And after that, it will make flag of 0 as false and come out from the loop. Let's say after that P1 want to execute, then it will execute, it will make flag of 1 as true, and it signifies that process 1 want to go into the critical section. So it will make it true, and it signifies that process 1 want to go to the critical section. Then turn, it will make it turn as 0. It will make it turn as 0. And then it will look for the condition. Condition says that turn equal to 0. Yes, it is true. Flag of 0 equal to true. Flag of 0 is not equal to true. It is false. So true and false, it will be false. Then it will come out from the loop and execute its critical section. And after that, it will make flag of 1 as false. Right. So this is how this particular solution takes place. Now let's go for the first condition. It says that mutual exclusion. Mutual exclusion says that if one process are in the critical section, no other process will be allowed to go into the critical section. So whether this particular thing, which means mutual exclusion, is satisfied or not. So here we have we'll see for the P0. We'll look for the P0 first to go to the critical section. So here it is flag of 0 is it true. So we'll make this particular flag of 0 as true, and then turn as 1, and this particular turn value as 1. And after that, we'll see the condition turn equal to 0 and flag of 1 equal to true. Turn equal to 0 is true, but flag of 1 is not true. It is false actually. So it will not execute the loop, while loop. It will go out from that and it will execute the critical section. Once it will be in the critical section, it will execute it. And let's assume that here we have the preemption. Means what? Means P0 is there in the critical section. Can we allow other process to go into the critical section? No, we do not allow if we want to satisfy this criteria, which is a mutual exclusion. Let's see this solution is satisfying or not. Let's say at that particular time, P1 want to go to the critical section. So what it will do? It will make a flag of 1 as true, means flag reports that any process is interested to go into the critical section or not. It says that yes, P1 want to go to the critical section. It will make it true. Then it will make it turn as 0. So whatever turn value is, it will make it 0. Right? And after that, it will go to the loop. The condition. The condition is turn equal to 0, yes, and flag of 0 equal to true. Flag of 0 equal to true. Then it is satisfied. If it is satisfied, it will be in a loop. Means both are true, right? This is true, this is true. So it will be in a loop. It means that P0 is in the loop and P1 is in the loop, and P1 will not allow to execute its critical section. Why? Because P0 is already there in the critical section. So in that way, we can say that because P0 is already there in the critical section, and P1 is interested, but it cannot allow to go into the critical section. Instead, the P1 will be in a loop. And what is the condition for that? The condition is, it says that the interested value of P0 means interest value of P0 means flag of P0 will be false. Then only will come out from the loop. Otherwise, it will be true. So it will be false after P1 will go into the exit section. P0 will go into the exit section. What is the exit condition? Is P0 is equal to false. Once it will do that, then only P1 will be allowed to go into the critical section. So this is how it happened. So in this particular code, we can say that it satisfies the mutual exclusion. It means our first solution, second solution, and this third solution, all these solutions will satisfy the mutual exclusion. Yes. So now we'll go for another criteria, which is called progress, whether progress is satisfied or not. Let's see this. This is the initial condition. So let's assume that P1 is executing first. So if P1 is executing first, so it will make flag value as true, right? And it will make turn value as 0. So it will make turn value as 0, and it will go to the loop. Loop says that turn equal to 0 and flag 0 equal to true. Now here at that particular time, let's assume that, yeah, so here what will happen is flag of 0 equal to true. No, it is false. So it will go into the critical section. And right now, who is in the critical section? P1 is in the critical section. It is executing its critical section. Now you assume that now here when P1 is in the critical section, here we have a preemption, and P0 want to execute into the critical section. So what it will do? It will make flag as true. Flag as true. And it will make turn as 1. It will make turn as 1. Right? And then it will go into the condition. Condition says that turn equal to 1. Yes. Flag equal to true. Flag is also true. So P0 will be in a loop. But it shown its interest. Now what will happen? Now let's assume that P1 is executing. So because here it is preempted, so P1 will execute its last code, which is flag 1 as false. Flag 1 as false. So we'll make flag 1 as false. This one as false. Now, can we say that P1 again go to the critical section? Let's see. P1 want to again go to the critical section, so it has to make it flag of 1 as true. This flag of 1 as true. And turn as 0. Turn as 0. Here at that particular time, actually P0 is in the loop, right? It has not allowed, but P0 shown its interest as true. So now what is in the loop? Loop is, it says that equal to 0 and the flag of 0 equal to true. So yes, it is true. So P1 is not allowed to go to the critical section. So P1 is not allowed to go to the critical section, even though it want to go to the critical section. Why? Because another process has shown its interest to go to the critical section. So here what will happen is, here we are we are having that progress. Progress is that if one process is interested, another process will not going to stop it. So progress will be achieved here. As well as we are not forcefully saying that that process has to go to the critical section. Means there is no strict alternation in this particular code. Means it is not says that if P1 is interested, it can go any number of time. But if at that same time, if P0 is interested, then P1 will not allow. Are you getting it? So if P1 is executing, then again P1 can go next time. Again P1 can go in next time. That is okay. But once P0 is interested, then P0 should go to the critical section. At that particular time, let's say P1 is interested, then P0 will not allow to go to the critical section. Instead, P1 is going to execute in the critical section. So whatever process is interested and showing its interest will be allowed to go into the critical section. So here we can say that progress is achieved. Now what about the bounded wait? Here bounded wait is also achieved. If one process is waiting, another process will not going to allow to the critical section. If one process is waiting, so other process who has already done its execution with the critical section again will not allow the same process to go to the critical section. So here bounded wait is also achieved. So both the condition is satisfied. Let's go to the deadlock condition, whether the deadlock condition is there in the progress or not, which we have seen in the last class, in the last solution. So what was the condition? The condition was, let's say P0 is executing its first execution for the critical section. So what it will do is, it will make flag 1 as true, turn as 0, and in the while loop it says that flag of 0 is equal to true, but here it is false. So it is not going to satisfy and it will execute its critical section. सर हाँ सर आ गया ठीक 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 है मैं भेज रहा हूँ जो फर्स्ट फ्लोर में बैठे हैं सर Let's see the last condition, which is the condition of the progress where we have seen the deadlock. Now let's assume that P1 is executing its code and P1 has make it true and make it turn as 0, and it will execute this while loop. It says it is unsatisfied and the condition is false, then it will come out and execute its critical section. Now here what will happen is, here let's assume that these two code has been executed, and here we have the preemption just before the loop. Now here preemption will take place and P0 is going to execute. Now if P0 will going to execute, it will make it flag is equal to true. So it will make this particular flag as true, turn value as 1, so it will make it turn value as 1. And then it will go to the condition. Condition is turn equal to 1. Yes, it is satisfied. It is equal to 1. A flag is equal to true. Yes, it is also satisfied. It means it will be in a loop. So P0 is in the loop. Why P0 is in the loop? Because P1 is already shown its interest and you are not allowing it to execute. And P0 is coming and executing it. So we are not allowed. Now the same thing will happen. Let's see. So it is P0 in the loop, right? Can P1 is also in the loop? Let's see. P1 is executing right now because here is in the loop. So no need to execute the next condition because it's in the loop. Now come to P1. P1 has executed these two, right? And it will come here in the loop. It says that turn equal to 0. Turn equal to 0. No, it is not equal to 0. It is actually 1. So this condition is false. What about this condition? Flag of 0 equal to true. Yes, this condition is true. So this is true, but this is false. False and true, it will be false. So will come out from the loop and critical section is going to execute. So you can see here, even though P0 is waiting here, but P1 will execute. Once the P1 will execute, it will make it flag of 1 equal to false. Once it will do flag of 1 equal to false, because the turn value is 1 and this flag value was true previously, now it will become false and then P0 will execute. So you can see here, there is no deadlock. There is no deadlock situation. So progress has achieved without the deadlock. Bounded wait, we already know that if one process is waiting, so other process is not going to allow to execute itself again. So bounded wait is also achieved. And there is no deadlock. This particular solution, what we have seen today, is called Peter search solution. For two processes. This particular solution will satisfy all the criteria of critical section using two variable, turn, which is an integer variable, flag, which is a two value Boolean array, and with these two variable, with this condition, we can satisfy mutual exclusion, we can satisfy progress, as well as we can satisfy bounded wait. So all these condition has been satisfied. In the next class, we'll see the some of the gate question regarding this solution, and we'll try to understand it. And also we'll see another criteria which is called the hardware solution for the critical section. We'll see some of those hardware solution as well as the operating system solution for that critical section that we'll see. And after that, we have the concept of semaphore and mutex. So we'll see semaphore and mutex also for the same purpose, which is a critical section, and process synchronization. So how we are synchronizing the process means one process if it's executing, another process will not allow. So these things will be there. So process synchronization is there, but other than that, we have the condition like progress as well as the bounded wait also that we have to see. So all these things are there in